In this video, I will talk about introduction to statistics. Okay, so what is statistic? Statistic is a process of collecting the data, analyze the data, and make the data organizes to use in the future. Okay, so you sometimes you have to making decision from the data you have. Okay, using some statistic technique like calculating correlation, find the means, the medians, the standard deviation of the data set. Okay, sometime like that. Okay, so first I'm gonna introduce you some key terms we frequently use in statistics. Okay, difference between population and sample in statistics. Okay, so population is the entire group of data. Okay, so for example, you wanna interview all the people in America, right? In America, so all the American people is the population. Okay, and about the sample is a smaller group of data. So you collect the sample from the population. You collect like a small group of data from the population. This group of data is the sample. Okay. For example, you want to interview the American people, right? So this is impossible to interview all the American people because there are a lot of people in America. So you cannot interview all of them. You just only can interview a small group of them. For example, you can only interview the people in California or the people in New York, right? It's a small group of the American people. So it's called the sample, right? Okay, then I will talk about the symbol of population and sample. So the means of the population, okay? So it denotes as mu, and it's equal to the summation of xi over n. N is the number of data in the population. So the summation of xi, which means that you add all of the x together. Okay? About the standard deviation. This is STD is standard deviation. Okay? And this denotes as sigma. Okay? And this one equal to the square root of the summation xi minus the means square all over n. So this is how to calculate the standard deviation. About the sample, the mean of the sample is denoted as x bar, okay, is equal to the summation of xi over n. N is the number of data in the sample. So the mean of the sample look like the means of the population, okay? About the standard deviation, it's a little different from the standard deviation of the population. So it's denoted as s, right? And this is equal to the square root of the summation xi minus the means of the sample, which is x bar square over n minus 1. Okay, so in the population, the standard deviation divided by n, right? But in the sample, the standard deviation of the sample, you could see it divided by n minus 1. So this is the difference of between population and sample. Qualitative data and quantitative data. So qualitative data is the data talking about like categories. It's about categories like the categorical data. So for example, in the human body, the categorical data is your hair color, right? Hair color is the categorical data. Your eyes color, right? Your gender, right? In the human body, this feature is the categorical data. And about the quantitative data is always a number. So it's about numerical data. If you see a number like a data that you can measure or you can count like 7.5 or 6 or 8, this is quantitative data. So quantitative data consists of two types. The first one is discrete data. And the second type of quantitative data is the continuous data. I will talk about what is the difference of discrete and continuous data in the next video. So, for example, about quantitative data. So, for example, in the human body, we have the blood pressure, right? The blood pressure is the quantitative data because we can measure it. This is a number. It could be an integer number, or it could be a decimal number. The blood pressure, your age, right? Your age is a number, and your height. You can measure your height, right? Your weight. This feature is belong to quantitative data. Okay, so now we will go through some example here to make sure that you get familiar with this topic. So the number of pair of shoe you own. So this is quantitative data because you can count how many pair of shoe you have, right? This is the number. So this is quantitative data. The type of car you drive. So the type of car, it could be Honda, it could be Toyota, right? So this is not a number, it's a categorical data. So this is qualitative data, right? The distance it is from your home to the nearest grocery store. So this is a quantitative data. It's a number. The number of class you take per school year. So this is a quantitative data. The type of calculator you use. This is qualitative data because it's not a number, it's a categories. Okay. Weight of a wrestler. So this is the weight, right? So this is quantitative data because it's a number. Number of correct answer on a quiz. So this is quantitative data because it's a number of the answer. I will talk about discrete and continuous data. So both of this data is quantitative data. So discrete data is the data that you can count. So it is countable, right? So it's countable. So for example, like the children, right? You can count how many children. The the pair of shoe, right? You can count how many pair of shoe we have, and the people in the room, right? You can count how many people in the room. And the continuous data is the data that is uncountable. It means like you cannot count how much or how many does it. And something like measurement, right? Continuous data is from measurement, right? For example, your height, right? You cannot count your height. You have to measure it. Your weight, right? Uh, how long does it, right? So it's something like kilometer, right? And this is the difference of discrete and continuous data. Discrete is the data you can count. And continuous data is the data you cannot count. You have to do it by measurement. Okay. Okay, so we will go through some example. First, the number of text messages a student received in one day. So the number of text message, that is the data you can count, right? It's countable, right? So this is the discrete data. And the time in second it takes to finish watching a YouTube video. So the time you cannot count because it have second, it have minute, it have hour, so you cannot count. So of course this is continuous data. The number of times you press the retry button in a game. So this is discrete because you can count how many times you press the retry button, right? The height of a student in the class. So of course it is continuous because you cannot do it. You have to measure it. And the number of spelling mistake in an essay, right? This is discrete because you can count it. Body temperature, right? Body temperature measured in degrees Celsius. This is continuous. And the number of coins in your pocket. Of course, this is discrete because you can count how many coins you have, right? So this is some example of discrete and continuous data, and it shows that the difference of discrete and continuous data, right? It's all about relative frequency. And what is relative frequency? The relative frequency is the proportion of times a value occurs out of the total number of observation. For example, you flip the coin 20 times, right? So you get a head. So the relative frequency of the head is the proportion of time the value curve, right? So it's a head. So the proportion is going to be a over 20 because 20 is the total number of the times you flip the coin. So it's a over 20. So we will go over an example to make sure that you get familiar with this topic. So you have the data set, right? So you have to make the frequency table to find the relative frequency. So the frequency table look like this. So this is the value, the first column. And the second column is the frequency of each value. How many times the value appear, right? And the next one is the relative frequency, is the last column. Okay, so now the value. In this data set, we have to count how many unique value we have. So 1, 3, 2, and 5 is the unique value we have, right? So 1, 2, 3, and 5. I would list it in ascending order. So the frequency in the value 1, how many times the value 1 appear in this data set? We have 1, 2, 3. So it's appear 3 times. The frequency is 3. The number 2 appear 1 time, right? And the number 3 appear 1, 2, 3, right? 4 times. And the number 5 appear 2 times. So the frequency of number 5 is 2, right? So the relative frequency. Okay, so from here, the total frequency is 3 plus 1 plus 4 plus 2, which is 10, right? So the total frequency is 10 because you add all of them up. You add 3 plus 1 plus 4 plus 2, which is 10, right? So this is the total frequency. So you remember that the relative frequency is the frequency of the value over the total of frequency. So we're going to use the number 10 in this case. So relative frequency is the frequency of its value over the total. So the total frequency is 10, right? So the relative frequency of the value 1 is 3 over 10. The next one is 1 over 10, right? So, and the next one is 4 over 10. So this is simplified to 2 over 5, right? And the next one is 2 over 10, the relative frequency of it. And this is equal to 1 over 5, okay? So if you want to find the relative frequency, you just find the frequency of the value, and then you divide it by the total frequency, okay? So if you add all of them up, if you add 3 over 10 plus 1 over 10 plus 2 over 5 plus 1 over 5, it's going to be 1. Okay, so if you add all of them up, if you add all the frequency, the relative frequency up, you would get the total relative frequency is 1. Okay, so you have to make sure that the total relative frequency is 1 because this is the proportion out of the total, right? The proportion out of the total frequency. So it's got to be 1. The total got to be 1. I'm going to talk about how to make a frequency table and how to find the relative frequency and the cumulative relative frequency. So first of all, I'm going to draw a table. So this is the value. This one is the frequency. This one is the relative frequency. And this one is cumulative relative frequency. So first of all, in the column value, I'm gonna list all the number appear in this dataset, all the unique number. So I'm gonna list it from the lowest to the biggest. So 1 is the lowest, so 1. The next one is 2, and the next one is 3, right? The next one is 4 and 5, right? And then I'm gonna count how frequently the value appear. So number 1, 2. So number 1 appear 1 time, or number 1 appear 2 times. So the frequency of it is 2. The next one is number 2. Number 2 appear 1, 2, 3, 4. So number 2 appear 4 times, right? Number 3 appear 1, 2. Number 3 appear 2 times. Number 4 appear 1, 2 times. And so number 5 appear 2 times. All right. So the total number of data in the dataset is 2 plus 4 plus 2 plus 2 plus 2. It's got to be 12, right? The total data in the dataset. All right, guys. Next one we will find the relative frequency of the value 1. So if you want to find the relative frequency of it, we're gonna take the ratio of its frequency, which is 2. We take a ratio of 2 over the total frequency is 12, right? So see 1 over 6. And the next one, we want to find the relative frequency of the value 2. We just take the frequency of it over the total. This is 1 over 3. The next one, we're going to do the same. 1 over 6. And this is 2, right? The frequency of it is 2 over 12 is 1 over 6. The next one is 2 over 12, 1 over 6 as well. Right? So this is the total, right? So we will add it up. We will add all the relative frequency. So 1 over 6 plus 1 over 3 plus 1 over 6 plus 1 over 6 plus 1 over 6, and it's gonna be 1. Alright, so you have to make sure the total relative frequency is 1. So the next one, we're gonna find the cumulative relative frequency. So this is 1 over 6, right? So we just rewrite 1 over 6. And the next one, if you want to find the cumulative relative frequency of the value 2, we will add 1 over 6. We will add 1 over 6 and this value and 1 over 3. So it's going to be 1 over 2, right? The next one, you want to find the cumulative relative frequency of the next value. We just add it up as 1 over 2 by 1 over 6. So its value is going to be 2 over 3. The next one you want to find, you just add it up at these two values, 2 over 3 and 1 over 6. And it's going to be 5 over 6. And next one we will add it up, so it's going to be 1, right? So this is the way how to find the cumulative relative frequency. And we talk about level of measurement in statistics. So we have 4 types of data: nominal data, ordinal data, interval data, and ratio data. Okay, so what is nominal data? Nominal data doesn't have order. It doesn't have an equal interval, and it doesn't have a true zero. So what does that mean? Okay, so nominal data, for example, is like nominal data, some kind of like categorical data. For example, you have the color. So you have the color blue, red, and green, some kind like that. And then you label this data. So for example, you label 1 for the color blue, 2 for red, right? 3 for green. Okay, so this is categorical data, and so it doesn't have order, right? Because you cannot compare blue, red, and green. Like it blue is 1 doesn't mean blue has a high ranking than red, right? Red is 2 doesn't mean red is higher than green. Okay, so it doesn't have order. Okay, it doesn't have equal interval because 2 minus 1, right? Like 2 minus 1 is 1, right? But you cannot take subtraction of red and blue. You cannot take red minus blue because it's not legit. So it doesn't have equal interval, okay? It doesn't have true zero because this is label. You label it, so it doesn't have true zero, right? Ordinal data. Ordinal data has order, doesn't have equal interval, and doesn't have a true zero. So what is ordinal data? For example, in a competition, the first rank is James, okay, and the second rank is Emma, and the third rank is, for example, Tom, okay. So this also categorical data. So ordinal data has order because James is first ranking. So James has a higher ranking than Emma, okay, and Emma have a higher ranking than Tom, okay. Tom had a lower ranking than Emma. So ordinal data has order, okay. Doesn't have equal interval because you cannot compare Emma and James. Like you cannot compare how far James and Emma. You cannot measure the gap between Emma and James. Cannot measure the gap between Tom and Emma. So it doesn't have equal interval. Okay. It doesn't have a true zero because you cannot find a subtraction, you cannot division, you cannot multiply or like something like that. You cannot measure that. It's just a label, so it doesn't have a true zero. Okay. Interval data. Interval data has order. Why? For example, calendar. Calendar is interval data. For example, 2020, right? 2021, 2022, 2023. Okay, it's interval data because it has order. Okay, it's like 2023 is higher 2022, right? Of course, 2022 is higher than 2021, right? The calendar, the year has equal interval because between this year and this year is 1 year, right? Between this year and this year is 1 year. Like, yeah. Between this year and this year is 1 year, right? So it has equal interval, okay? And then it doesn't have a true zero. So, for example, temperature, okay? So, 0 degree, 0 Celsius. 0 Celsius is data, but it doesn't mean that we don't have temperature. 0 Celsius is temperature. It doesn't mean we don't have temperature. See? So this doesn't have a true zero. Okay. Next one we're gonna go to ratio data. Ratio data has order. For example, weight of a human. Okay. So it has order because, for example, 170 pounds, right? Greater than 169 pound, right? It has order. You can compare the value of it. You can compare the data together. So set order. Okay. The ratio data has equal interval because between this because 170, 169, 168, right? The gap between them is 1 pound. Okay. So it has equal interval. It has a true zero because 0 pound means it doesn't have, like, they doesn't weight, right? Okay, so this is the summary table for you guys. So nominal data doesn't have order, okay? Doesn't have equal interval, doesn't have true zero, right? So it's like categorical data, like blue, red, green, like color, like the color of your eyes, something like that. So it's nominal data, okay? ordinal data. It has order. It doesn't have equal interval. It doesn't have true zero. For example, ranking of the competition, right? Interval data has order, okay? It has equal interval and it doesn't have true zero. So it's like years, it's like days, it's like months, it's like temperature. It doesn't have true zero because 0 Celsius doesn't mean it doesn't have temperature. 0 Celsius is a temperature. And the next one is the ratio data. The ratio has order, it has equal interval, and it has true zero. The ratio data has true zero that allow you to compare data together by taking the ratio of it or by find the difference between it. If this video is helpful, don't forget to give me a like, subscribe. Thank you so much.